Okay, hello all. So welcome to the online learning, and we're going to start a new topic, which is index notation. So index notation is a way that we can represent numbers, and so what I want you guys to think about is this. Okay, so here's a little thing for you, and I always like saying this one because it always picks people off guard. Okay, so say you put money into a raffle, and sorry, you buy a ticket in a raffle, and you win. You won the raffle, and you've got two options. Okay, so you got prize one, you got prize two. Okay, so let's say prize one is you get $1,000 right now. Okay. So you take your ticket up, they say, okay, here's $1,000, here you go. Cool. Okay, seems pretty easy. Or prize two is 1 cent, but they double it every day for 20 days. Okay? And so the option is now, which one of these prizes do you pick? Okay? And I'd be intrigued to know what you guys actually think. Like, which of these prizes would you go for? Like, would you legitimately go for? Is there a better prize? Okay. Now, just by looking at it to begin with, you're probably thinking, well, prize one, like $1,000 now. I get it right now. I can go buy a maybe a new phone or something like that. Pretty straightforward, pretty standard. That seems pretty cool. Okay. But how much are we actually going to get from this second prize? Like, how much money are we actually getting? Well, 1 cent. Okay, this is day one. Okay, day two. Okay, well, how much would it be in day two? Well, it would be 2 cents. Okay, so in total you get 3 cents. Okay, but then after this it'd be 4 cents, and then it'd be 8 cents, and that's 4 days already, and you've only made 13, 14, 15 cents. Like, that doesn't seem a lot. But what I'm going to do is I'm going to grab this calculator over here. And I'll show you what I'll do. I'll go 0.01, and I'm going to times it by, well, sorry, I'm going to add it. I'm going to add 0.01, aren't I? Okay, plus, because I'm doubling it each time. So 0.02. Okay, then I double it, you get 0.04, and I double it again, you get 0.08. Okay, so what did we say? That was day 4. Then this is day 5. Day 6, 32 cents, not much. Day 7, 64 cents. Okay, it's still not much money. Day 8 is $1.28. Still seems like it's not much money. So only after day 8, it's still only $1.28. So I'll write that down here. So day 8 is $1.28. Okay, so it seems like this is not a really good deal. $1,000 looks pretty good to me. Let's double it again. Okay, we get $2.56. So that's 9. Day 10, day 11. Ooh, what's happening? It's growing a bit quicker. Day 12, day 13, day 14, day 15, day 16, day 17. So day 17, it's $655. Day 18 is 1,310. Look, at day 18, okay, we're not even at day 20 yet. It's already gone over 1310 72 cents. So day 14, day 19. Look at that, it's 2,000, and then day 20 is $5,242. Now it seems really weird that from 1 cent this number could grow so much. Well, excuse me. This is what we call an exponential, because it's growing at an increased rate. Like, it's growing at a rate which is like essentially doubling as it goes. Now imagine if I said triple. Imagine how quickly that would grow if that value tripled. Like, look at this, like times 3. Like, it grows so much quicker each time we do it. But obviously I don't want to sit here forever and ever and ever keep typing in like this value. I don't want to keep typing it in. So what I could do instead, if I really wanted to, is I could write out my calculation. So what was the value I started with? Well, it was 0.01, and it's times 2. Okay, and then we times it by 2, and we did this, and we did this 20 times. Okay. Now that was a lot of calculations to do. But one thing we could do to make this so much quicker for us is we could actually multiply it by what's called a by what's called an indice or an index. Okay, and what an indice or an index is, and you guys may have seen this before. Instead, I could write it as 0.01 times 2 to the power of 20. Okay, because 2 times 2 times 2 is the same as 2 to the power of 20. And think back to some things that you know. Well, you guys should know that like 2 times 2, for example, is 2 squared. Or 2 times 2 times 2 is equal to 2 to the power of 3. And this pattern actually keeps on going. Like, we don't stop just because it's only 2 or 3. Like, this pattern keeps on going. And so depending on how many times you write it is the little number that you put up in that top right corner of the number. So if I did it 20 times, I would do 0.01 times 2 to the 20. So we did it before and we got like, what, 5,000 or something? Well, here we go. We've got day 18 was equal to 1310.72. And that was when I times it by 0.01. So if I do 0.01 times 2 to the power of, and so the amount of days it was, so it was 18 days. And we should get, ooh, I think I've gone one too many. 17 days. Maybe I miscounted. 1310.72. But the point is that this calculation here, this times 2 to the 17, makes it so much easier to work with than having to type in times 2 times 2 times 2 every single time you want to put it in. And so this is what we call index notation or index laws. So what do we know about index laws or index notation? Okay, well, let's write out a number. We'll do one like this. So we'll go like 5 times 5 times 5 times 5 equals 5 to the 4. Okay, and we're going to talk about some different components of this. So this bit here we call the expanded form. Okay, because this is what happens when we expand out, like we write all out 5 to the power of 4 to the power of 4 to, like 5 to the power of 4, like 5 times 5 times 5 times 5. Okay, and when we put it in this little form, we call this the index form. Okay, so expanded form, if I ask you to write something in expanded form, that means I want all the numbers written out. And if I ask you to write something in index form, it means I want it, you know, that big number to the power of how many there are. Now, some little key components. This 5 we call a base, okay? Because this base number is basically the number that we are multiplying. And then this small number up here we call the index. So this is our index up here. And so our index is how many times we're writing this out, basically. And of course, we could actually put this in our calculator and get a number. So if I put 5 to the power of 4, I get 625. And of course, this we call our, this is just a basic numeral, okay? Because that's just basically what the number is. It's just the number itself. So it's the basic numeral. The important bit is this base is the 5 and the index is the 4. So the number that appears, the big number that appears is the base. It's the number that appears in my expanded form. And the index is the small number, which is the amount of times that the base appears. So because my base appears 4 times, I'm writing to the power of 4. And we read this as 5 to the power of 4. And we've got to say it like that, 5 to the power of 4. Okay? Now, one little application of this we call the prime factorization. So prime factorization. Now, prime factorization is a cool little tool that can take a really big number and turn it back down into its index form, okay? And we want to turn it into prime numbers. So keep in mind what a prime number is. It's a number that can only be multiplied by itself and 1. And we'll start off with the number 24, okay? So let's think of some numbers that we can multiply to give 24. And it doesn't matter what numbers you pick. Okay, I'm going to pick 4 and 6. Okay, 4 and 6 are my two numbers. Okay, now from 4, well, what are some numbers that multiply to give 4? Okay, what are some numbers you can think of that multiply to give 4? Well, I can think of 2 and 2. Okay, now the only numbers that give me 2 are 1 and 2, so there's no point going because I'd go on forever and forever, and because it's a prime number, I'm going to stop. That's it, I'm finished. Now let's think about 6. Okay, so what are some numbers that multiply to give 6? And particularly any prime numbers that multiply to give 6? Well, we've got 2 and 3, okay? So 2 times 3 is equal to 6, cool. And then 6 times 4 is equal to 24. So what this is basically saying is if I've got 2 times 2, that gives me 4. And if I've got 2 times 3, that gives me 6. And if I do 4 times 6, that should give me 24. So what that means is that 24 should be equal to 2 times 2 times 2 times 3, and which it is. Okay, so I'll write down here. So 24 is equal to 2 times 2 times 2 times 3. And if we were to write that in index form, okay, we've got the 2. How many times does the 2 appear? Well, it appears 3 times. Okay, and then how many times does the 3 appear? Well, the 3 only appears there once, so we just write times 3. We don't have to put a power of 1 there, okay, because 3 to the power of 1 is just 3 anyway, so we can leave that as it stands. Okay, so that's basically the start of this one, guys. There's going to be some questions for you guys to have a go at. Basically, what you're going to do is you're going to do some of this expanded form, so you're going to be writing these guys into this one, or you might be writing these ones into that one, okay? And there will be 1 or 2 questions on some prime factorization. So good luck, and if you have any questions, make sure you let me know, okay? Yeah, so good luck, and I hope it all goes well.